So our cover crop mix, we were interested in a couple goals. We wanted forage for our livestock. We wanted to be able to fix some nitrogen for our corn crop that's going to follow this. And we wanted to have a really diverse mix of species. We wanted some flowering species, some grass species with some different rooting patterns that allow us to do different things within the soil profile. And so we have a diverse mix of cover crops here that hopefully allow us to meet those goals.
That really allows us to plant pretty much whatever we want as far as cover crops go after a small grain harvest, and that's what got me interested in it initially. Kind of growing our own small grain for our own use, harvesting it in July, and saving that seed either to feed or for planting somewhere else the following year. And after you have that harvested off, the world is your oyster as far as species that you can plant for cover crops. And really you start to get into a lot of diversity for species and for roots for your soil.
Particularly in a no-till or reduced tillage type of cropping system, you can get nutrient stratification where applied nutrients remain at the top and soil nutrients remain deeper in the ground. And so having those different rooting patterns as well as the different associations with soil microbes can allow those nutrients from deeper in the ground to be pulled up by a deep-rooted plant, converted into residue, crop residue, that's then broken down on top of the soil surface and decomposed on top of the ground. And so you have that exchange of nutrients from deeper in the profile to shallower in the profile. And that, as it breaks down into organic matter, can allow us to absorb more water, hold more water, have better infiltration, and also will recycle some nutrients back to us for years to come.
The main goal, and this is kind of our long-term goal, 5 to 10 year goal, is to increase the water holding capacity of that soil, increase the nutrient holding capacity of that soil, and also to give our soil biology something to eat, something to function on for as many months out of the year as possible.
If you study the components of what is required to have healthy soil on your farm, first and foremost, you have to understand that soil is it's a very diverse mixture of a lot of different things. You've got minerals in the soil, you've got organic matter, you've got water, you've got air. But for a long time, one of the critical pieces that's been neglected and oftentimes missing in most farm fields, including ours, is having a proper and healthy balance of bacteria and fungi and all of the other microbial life in the soil that are required to create soil structure, that are required to release nutrients so that plants can use them, that are required to basically maintain all of the components in the soil profile that are necessary to allow it to be productive for plants, that allow it to be held in place when you get heavy rainstorms instead of washing off the field. Oats, really any type of green plant growing on a field as much of the time as possible, as long as it's putting roots into the soil profile, is going to provide the environment that's necessary for the right mixture of different types of microbial life to thrive and to prosper there. And as that happens, they start to build health back into the soil.
Crop residues, manures, and other organic matter amendments serve as food for soil microorganisms. And if you apply more food, more things come to eat. Diverse communities of microbes typically have a lot of redundancy. You have things doing more or less the same thing, but the idea is that the community is better able to provide the health and nutrient cycling functions and the soil building functions when it has a better diet. The kinds of things that microbes consume are diverse, and we supply diverse feedstuffs in the form of clover and alfalfa residues, crop residues from the oat crop in the more diverse rotations differ from just the corn and soybean residues we'd be applying. Manure itself contains healthy amounts of microbes, but also contains quite a bit of carbon and other nutrients that serve as substrates for those microbes to consume. So by adding food to the soil, we stimulate populations of microbes. They initially consume the carbon and the nutrients, and then as they die off, they release those nutrients back into plant available form. In the process of living in the soil and building their colonies and communities, they alter soil structure, and they can create a more crumb-like structure, better tilth, more airspace. And we've seen reductions in what we call bulk density, the amount of air in a given volume of soil, and that allows easier penetration of roots into the soil, and it also allows greater exchange of oxygen, which roots need to respire in the soil.